Hello dear students, in this video I will continue with the 5th unit, which is Inferential Statistics. In this video we will learn about hypothesis testing and we will see what is small sample test or t-test for one sample. Now before seeing hypothesis testing, we will have a recap of what we have already studied. So we have studied about population and sample. Here this population is nothing but it is the entire group of individuals or objects or members about which a researcher is interested in or about whom a researcher wants to draw conclusions about. Since it is difficult to obtain data from each and every individual or object of the population, what the researcher will do? The researcher will draw a small set from this largest set called population. This small set is called sample. So if we have population, the total number of members in the population, it is the population size given by capital N, and the total number of members in the sample, it is known as sample size. Population size is denoted by capital N and sample size is denoted by small n. Now to draw this sample from this population, we have various methods. The process of drawing a sample from the population or the technique of drawing a sample from the population is called sampling. Now this process can be done using various methods. It is broadly categorized as probability sampling and non-probability sampling. About various methods we have already seen. And then we have what is called parameter and statistics. So all those numerical values or characteristic of a population is called a parameter. So if we calculate the population mean, say mu, or if we calculate the population standard deviation, it is given by sigma. All those will come under this parameter. Whereas if we take statistics, it is a characteristic or numerical value of the sample observations alone. So if we find the sample mean denoted by x bar, or if we find the sample standard deviation denoted by S, all these are sample statistic. Next we have sampling distribution. Sampling distribution, it is the distribution of any sample statistic. It can be the distribution of either mean or standard deviation and so on. Such a distribution is called sampling distribution. Next we have standard error of mean. Now to check whether the sample that we have drawn is a true representation of the population or not, we can find the standard error of mean. The standard error of mean, it is calculated as sigma m equal to sigma upon root n. Here sigma is the population standard deviation and this small n is the sample size. So using this formula we can find standard error of mean. If this sigma m is large, it means our error is more. If this is small, then our sample is a better representation of the population. In last year's sample paper, a question on standard error of mean, it was asked for 2 marks. Next we have central limit theorem. As I already mentioned, it is a very important theorem in statistics. According to this theorem, any sampling distribution will lead to become a normal distribution as the sample size increases. So for central limit theorem to hold, we need to have a sample size of more than 30. In that case, we can assume that the sampling distribution will lead to normal distribution. Next we have confidence level. Confidence level, it shows the precision and uncertainty of a sampling. So if we have alpha as the level of significance, then the confidence level is given by 1 minus alpha. So usually it is given by 95%, 98% or 99%. It shows how much the researcher is confident about the various values. So that is confidence level. And next we saw what is hypothesis. So now to draw conclusions about a population, the researcher has to make certain assumptions about the population. Such assumptions are called hypothesis. It is a tentative declarative statement of a population parameter. This hypothesis, it can be either null hypothesis or alternate hypothesis. This null hypothesis, it is a statement of no difference. So here basically null hypothesis states that there is no difference between any two groups mean. On the other hand, the alternate hypothesis is just the opposite of null hypothesis. It states that there is significant difference between two groups. So this is with respect to hypothesis. Next we have degrees of freedom. Degrees of freedom, it is denoted by nu and it is equal to the sample size n minus 1. Degrees of freedom is, it is nothing but, it is the number of independent pieces of information on which an approximation is based. It is usually calculated as the sample size minus 1. In this year's sample paper also there is one MCQ which is asked where we have to find the degrees of freedom. The sample size is given, we have to write what is the degrees of freedom. Only when we know degrees of freedom is given by this n minus 1, we can answer that question. So it was asked for 1 mark. Next we have level of significance. This level of significance, it is denoted by alpha. It is the probability of making a wrong decision when the null hypothesis is true. So as I already said, to draw conclusions about a population, the researcher will make assumptions about the population. Those assumptions are called hypotheses. So the researcher will write the null and the alternate hypothesis. Sometimes there are chances that the researcher will reject H0 when it is true. That probability of rejecting H0 when it is true is called level of significance. So it is given by alpha. So all these we have seen in the previous video. Now with all these in mind, now let us start with hypothesis testing. After stating the hypothesis, the researcher designs the study. So once the hypothesis is stated or once some assumptions about the population is made, the researcher will select the correct statistical test, chooses an appropriate level of significance alpha and formulates a plan for conducting the study. So after this hypothesis testing, it is a step-by-step procedure. Next we have another point to note. If we discard the null hypothesis, then we assume that there is enough evidence to support the alternative hypothesis. So the researcher is making some assumptions about the population using the null and alternate hypothesis. If we get the conclusion as we reject this null hypothesis, then we assume that there is enough evidence to support the alternate hypothesis. Now as we do problems, we will understand each of these terms in detail. Next we have what is called the one sample t-test. So this one sample t-test, it is a statistical test for mean of population and it is used when the population is normally or approximately normally distributed with an unknown variance. So this one sample t-test is used to test whether the mean of a population is equal to some value. Say for example, if the mean of the population is given by mu, we use this one sample t-test to test whether this mu is equal to some mu naught. We use this one sample t-test when the population is normally or approximately normally distributed and the variance, the population variance is not known. Sigma square is unknown. Now let us see. Now this was discovered by a person by the name student. So it is known as student's t-statistic. Now let us take let x1, x2 up to etc. xn be a random sample of size n from a normal population with mean mu and variance sigma square. We do not know this sigma square. Then student's t-statistic, it is given by t equal to x bar minus mu naught upon standard error. Now what we have learned about standard error? The standard error we know it is given by sigma by root n, where sigma is the population standard deviation. But sigma square is unknown. We are using this statistical test when sigma square is unknown. So we do not know what is sigma. As a result, what we have here is it is equal to x bar minus mu naught upon capital S upon root n, where this capital S it is an unbiased estimator of sigma square. So where S square is given by, capital S square is given by 1 by n minus 1 summation xi minus x bar the whole square. In unit 4 we have studied about expected values. So if we have a random variable x, then the expected value of x is nothing but it is the mean x bar. Similarly, here we need to have expected value of something to have this sigma square. So here the expected value of this S square, it is sigma square. So only when we have this capital S square which is given by 1 by n minus 1 into summation xi minus x bar the whole square, we have the student t statistic given by x bar minus mu naught upon capital S by root n. But usually in the question only the sample standard deviation will be given or the sample variance will be given. The sample variance is given by small s square. It is 1 by n summation xi minus x bar the whole square. Now this formula we have studied in class 11 itself for variance. So when the sample variance is given, s square equal to 1 by n into summation xi minus x bar the whole square, or if the sample standard deviation small s, if this is given, then we have t as x bar minus mu naught upon small s by root of n minus 1, or it is x bar minus mu naught into root of n minus 1 upon s. Where sample variance s square is given by 1 by n into summation xi minus x bar the whole square. Since there is usually a lot of confusion with this capital S square and small s square, it is better to proceed with this formula itself always. So always let us use this formula alone. Actually both these are correct. If we substitute capital S and find the answer, we will get the value of t. It will be equal to the value of t which we get when we substitute small s also. But to avoid confusion, let us use only this formula. So t is equal to x bar minus mu naught upon sample standard deviation, yes, upon root of n minus 1. In last year's sample paper, a question on t-test was given for 3 marks. The same question we will solve at the end. Now we will see the steps involved in using t-test. Procedure for testing the hypothesis by using the t-test. So the first step is we have to state the hypothesis. So we have to state what is the null hypothesis H naught. So it is usually given by mu equal to some value, say mu naught, and the alternate hypothesis H1 is given by mu naught equal to mu naught. The next step is we have to define the statistic, that is the t statistic here. So it is given by t equal to x bar minus mu naught upon small s by root of n minus 1. So this is the test statistic t. The third step is find t. We have to find the value of t and we have to compare this value with the critical value of t from the table with n minus 1 degrees of freedom at alpha level of significance. So we have to use the table. We have seen in unit 4 normal distribution table. Similarly for this t distribution also we have table for various degrees of freedom and for different levels of significance. So based on the required degrees of freedom and level of significance, we can find the critical value of t from the table. So that is the third step. The fourth step is we have to make a decision to accept or reject H naught based on this critical value of t. How we go about with this step, we will understand when we see problems. And the last step is we have to summarize the result. So these are the steps involved in hypothesis testing using t-test. Now from the beginning we have been seeing small sample test, small sample test. Now what is the small sample test? When the sample size is less than 30. When the sample size is less than 30, in that case we have to use only this t-test. That is why we call this as small sample test. So it is a test that is used for small samples. We already saw for central limit theorem to hold, the sample size should be large. But not always we will get samples whose size is large. Sometimes we have to deal with small samples. In that case, we can use this t-test. Here are few points to note. If the population is roughly normally distributed and the population standard deviation sigma is unknown, then only t-test should be used. If this sigma is known, then we have to use some other test. It is beyond the scope of this syllabus. Then the next point is perform a two-tailed test if you want to see if two populations are different from one another. So if we have to test a hypothesis of this form, that is H naught is mu equal to mu naught and H1 is mu not equal to mu naught. In this case, we have to perform a two-tailed t-test. Next, we have perform one-tailed t-test if you wish to know whether one population mean is greater than or less than the other. So on the other hand, if we have a null hypothesis as say mu greater than or equal to mu naught, an alternate hypothesis as mu less than mu naught. In this case, we have to use one-tailed t-test, or it can be H naught is mu less than or equal to mu naught and H1 is mu greater than mu naught. In that case also, we have to use one-tailed test. So this is a lower tail test and this is upper tail test. Now we will see in the next slide what is all these. So these are some of the points to be noted and these are the steps to perform hypothesis testing using t-test. And now we will see the rejection rule using critical value approach. So the entire idea of this hypothesis testing is to check whether the assumptions that is made on the population is true or not. The assumptions that we make on the population is depicted using the null hypothesis and the alternate hypothesis. Now when we can reject this null hypothesis, that will be summarized here. First we will take the lower tail test. In lower tail test, the hypothesis takes the form, the null hypothesis is given by mu greater than or equal to mu naught and the alternate hypothesis is given by mu less than mu naught. The test statistic t is given by t equal to x bar minus mu naught upon s by root of n minus 1. Now we will see the rejection rule. We have to reject H naught when t is less than or equal to t alpha for n minus 1 degrees of freedom. So this T alpha we calculate from the T distribution table. So we can find the value of this T alpha from the T distribution table. For alpha level of significance and n minus 1 degrees of freedom, we will find this value and we will reject H naught if the T that we have calculated is less than or equal to the table value. This is the critical value of T. If this calculated T is less than or equal to the critical value, then in this case we will reject H naught. Next we have the upper tail test. In this upper tail test, the hypothesis is given by mu less than or equal to mu naught and the alternate hypothesis is mu greater than mu naught. The test statistic is the same. It is T equal to x bar minus mu naught upon s by root of n minus 1. In this case, we reject H naught when this calculated value of T, it is greater than or equal to the critical value of T. And next we have the two-tailed test. So the two-tailed test, it is given by H naught is mu equal to mu naught and the alternate hypothesis H1 is mu not equal to mu naught. In this case also the test statistic is x bar minus mu naught upon s by root of n minus 1. In this case we reject H naught if T is less than or equal to minus T alpha by 2 or T is greater than or equal to positive T alpha by 2. So these are the rejection rule for various types of test. Luckily, as far as the syllabus for 2022-23 is concerned, we have only this non-directional hypothesis. As a result, we have only this two-tailed test. But there are some questions where we have to use lower tail test or upper tail test. So there is nothing wrong in knowing what is this lower tail test and upper tail test. But usually we can expect questions only from two-tailed test. Now what is this? How we can understand this? Calculated value of T, it lies in this interval. Here also for n minus 1 degrees of freedom. Now we will see what is this rejecting H naught when T is less than or equal to minus T alpha by 2 or T greater than or equal to T alpha by 2. Now let us say suppose the level of significance alpha is 5%. We have alpha as 5%. It is nothing but it is 0.05, which is the area under the T distribution curve. So the T distribution curve is also similar to standard normal distribution curve. If the degrees of freedom is more, then the T distribution curve resembles the standard normal distribution curve. When we have alpha equal to 0.05, so this 0.05 is the area under this curve. Under this two-tailed test, we have T alpha by 2, that is 0.025 on one side and 0.025 of the area on the other side. So here we have negative T alpha by 2, that is T 0.025. So here we have negative T 0.025 and here we have positive T 0.025. So this is the area of rejection. This part and this part is the area of rejection. So if we get the value of T in this range, then we can accept H naught. On the other hand, if we get the value of T, if it is less than negative T 0.025 for n minus 1 degrees of freedom, or if it is more than T 0.025 for n minus 1 degrees of freedom, then we will reject H naught. So these regions, they are called the rejection region. So these two regions, they are called rejection region. and this part is the region of acceptance. So if the calculated value of t, if it lies in this interval, then we can accept h naught. On the other hand, if this value of t lies here or here, we will get some value of this t 0.025 for the given degrees of freedom. If this value, if it lies in this interval, then we have to reject h naught. As we do problems, we will understand this better. So this is with respect to lower tail test, upper tail test and two tail test. So first step is we have to write the hypothesis h0 and h1. Now based on the hypothesis, we have to see whether it is a two tail test or upper tail test or lower tail test. If we have alternate hypothesis like this, then it is a two tail test. If we have hypothesis like this, then it is upper tailed, and here we have the lower tailed test. Then we have to find the test statistic t, and we have to make decision based on the value of this critical value of t for n-1 degrees of freedom. Now let us see an example question to understand all the terms that we have studied and the steps in hypothesis testing. Now this question I have taken from R.D. Sharma book of Applied Mathematics. It is given 10 cartons are taken at random from an automatic filling machine. The mean net weight of the cartons is 11.8 kg and the standard deviation is 0.15 kg. Does the sample mean differ significantly from the intended weight of 12 kg at 5% level of significance? So here a sample of 10 cartons, it is taken at random from an automatic filling machine. Then the mean net weight of these 10 cartons is 11.8 kg and the standard deviation is 0.15 kg. Now we need to test whether this sample mean differs significantly from the intended weight of 12 kg at 5% level of significance. So our hypothesis is we have to test whether this sample is drawn from a population having mean of 12 kg. So here we have 10 cartons included in the sample. So this is the sample size n. The mean net weight of these cartons, it is 11.8 kg. So this is the sample mean x bar, and this is the sample standard deviation small s, which is 0.15 kg. So first let us write what all we know. N is 10, sample mean is 11.8 kg and sample standard deviation is 0.15 kg. The first step is we have to define the hypothesis. Define null hypothesis H0 and alternate hypothesis H1 as follows. So H0 is, we usually have H0 as mu equal to some constant mu naught. Here we have to test whether the sample mean differs significantly from the intended weight of 12 kg. So H0 is mu equal to 12 and H1 is mu not equal to 12. So usually null hypothesis is a statement of no difference. So there is no difference between population mean and 12 kg. So here we have H0 as mu equal to 12 and H1 is mu not equal to 12. So by seeing this, we can see that it is a two-tailed test. Thus, a two-tailed test is applied under hypothesis H0. We have t equal to x bar minus mu upon small s upon root of n minus 1. So it is x bar minus mu upon small s into root of n minus 1. So here x bar is 11.8, x bar minus mu naught. We can write mu naught or mu, there is nothing wrong. 11.8 minus 12 upon s is 0.15. 0.15 into root of 10 minus 1. So it is negative 0.2 upon 0.15 into root 9. So it is negative 0.2 into 3 by 0.15, which is equal to negative 4. So the calculated value of this test statistic t is negative 4. Now we have to find the critical value of t or the table value of t at 5% level of significance and n minus 1 degrees of freedom. So the degrees of freedom nu is n minus 1. So it is 10 minus 1, which is 9. So from the table, so let us find the critical value of t for 5% level of significance and 9 degrees of freedom. So if we see here, we have the 9 degrees of freedom, and here we have area in one tail and area in two tails. So this table is given in the handbook. So for alpha equal to 5% and 9 degrees of freedom, we have area in two tails, it is given by 2.262. Usually to find the region of rejection for a two-tailed test, we will have the rejection region on both sides. So here we have negative t 0.025 and here we have the value of positive t 0.025. So this area is 0.025 and this area is 0.025. Now here, if it is given area in one tail and area in two tail, then we can see area in one tail, it is 0.025. So the value for this negative t 0.025, it is 2.262. So this point on the x-axis, it corresponds to negative 2.262 and this point corresponds to positive 2.262. So from the table, t 0.025 for 9 degrees of freedom is 2.262. Now we have to compare the calculated value of t with the critical value of t. As I already said, the region of rejection is on both sides. Here we have negative 2.262 and here we have positive 2.262. So if we see this negative 4, it lies in this region. It does not lie in this region. So we have to reject H0. Since t equal to minus 4 does not lie in the interval, negative t 0.025 to positive t 0.025 for 9 degrees of freedom, that is negative 2.262 to positive 2.262. We reject H0. So this value negative 4, it lies in this region of rejection. As a result, we reject H0 and we conclude that the sample mean differs significantly from the intended weight of 12 kg. So whatever we have to find out that is given in the question, that should be written as the result. So we need to check whether the sample mean differs significantly from the intended weight of 12 kg. Accordingly, we have to set the hypothesis. If we get the result to reject H0, then we have to write the results accordingly. So here, if we reject H0, then we have enough evidence that we can accept the alternate hypothesis H1. So we conclude that the sample mean, it differs significantly from the intended weight of 12 kg. So this is how we have to go about in hypothesis testing. Similar question was given in last year's sample paper for 3 marks. Writing the hypothesis carries 1 mark. Then finding the value of t carries 1 mark. Then writing this step and the final answer carries 1 mark. Now let us see the question on hypothesis testing from last year's sample paper, which was asked for 3 marks. A machine produces washers of thickness 0.5 millimeter. To determine whether the machine is working in proper working order, a sample of 10 washers is chosen for which the mean thickness is 0.53 millimeter and the standard deviation is 0.03 millimeter. Test the hypothesis at 5% level of significance that the machine is working in proper order. Given T 0.025 equal to 2.262 at nu equal to 9. So here it is given a machine produces washers of thickness 0.5 millimeter. So this is the mean thickness. So this is the population mean mu. We have to determine whether the machine is working in proper order when a sample of 10 washers were taken. It showed a mean thickness of 0.53 millimeter. So this 10, it is the sample size. 0.53 millimeter, it is the sample mean x bar, and standard deviation 0.03 millimeter. So this is the sample standard deviation small s. We have to test the hypothesis at 5% level of significance. So alpha is 5%. So we need not worry about looking into the table because usually the critical value of t for the required degrees of freedom, it will be given in the question itself. So let us define null hypothesis H0 and alternate hypothesis H1 as follows. So H0 is mu equal to 0.5 and H1 is mu not equal to 0.5. So here the machine has to produce washers of thickness 0.5 millimeter. It should not be more than 0.5 also. It should not be less than 0.5 also. The dimensions should be exact. Only then the machine is working in proper order. So we have H0 as mu equal to 0.5 and H1 as mu not equal to 0.5. So we have a two-tailed test. It is applied under H0. Thus, a two-tailed test is applied under H0. We have T equal to x bar minus mu upon s by root of n minus 1, or it is x bar minus mu upon s into root of n minus 1. So here x bar is 0.53 minus mu is 0.5 upon s is 0.03 into root of 10 minus 1. So this is 0.03 upon 0.03 into root 9, which is 3. So we get T as 3. The calculated value of T is 3. They have given the table value is T 0.025, it is equal to 2.262 at nu equal to 9. So they have already given the table value or the critical value of T. So here we can see that the calculated value of T which is equal to 3. It does not lie in this interval. So since it is a two-tailed test, we have region of rejection on both sides. This is negative T 0.025 or it is negative 2.262 and here we have positive 2.262. So this T equal to 3, it lies here in this region of rejection. As a result, we reject H0. So again we have to write since T equal to 3 does not lie in the interval negative T 0.025 to positive T 0.025 for 10 minus 1 equal to 9 degrees of freedom. We reject H naught. So if we reject H naught, we conclude that the machine does not produce washers of thickness 0.5 millimeter. As a result, the machine is not working in proper order. Hence, we conclude that the machine is not working properly. So, this is the conclusion. Here again, for writing the hypothesis, we have 1 mark. Then for finding the test statistic T, 1 mark. And then for writing the conclusion and summarizing the results, we have 1 mark. So, a total of 3 marks for this question. So, this is how we have to go about in hypothesis testing using t-test. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. Thank you for watching.